Okay guys, you're going to also need your periodic table and a calculator for today. So what we're doing today is isotopes. And I also kind of want to go back to what we finished off on Friday. Last Friday we finished with ions. So now ions are going to only deal with electrons. Okay? So no matter what element you use, an ion only affects your electrons. Okay, because your electrons change. No, hold on. Okay, so ions are going to change the electrons. What we're doing today are isotopes. So an isotope, in an atom, your neutrons change. You might want to write this down. An isotope is when you have an atom and your neutrons change. When your neutrons change, your mass will change as well. Okay, everyone should be unplugged. Everyone should be unplugged during the lesson. Yes. Okay. Now, because your neutrons change, your mass is going to change. Okay, so where ions deal with the electrons, your isotopes are going to deal with the neutrons. Okay? Did everyone get that definition? Okay, you don't need to write this whole frame down, just the definition I'm giving you. Okay? An isotope is when an atom has neutrons that change, therefore your mass will also change. Okay. Because your neutrons change, your mass will change. Yes, go ahead, sweetie. An isotope is when an atom has neutrons that change, therefore your mass will also change. Okay, now don't forget that this goes on your INB notebook on pain. Okay, so let's look at oxygen here. And let's say we have two different isotopes. So you have an oxygen that has a mass of 16. Remember that your nucleus, your protons plus your neutrons, is what gives you your mass, okay? So here I have 8 neutrons, and here I have 10 neutrons. This is why my mass here is 16, and here my mass is 18. Okay, so we see that? Because your neutrons change, your mass will also change. Okay? Now you can have a sample of 2 isotopes, 4, 8. You can have 15 isotopes, okay, in a given sample. Now, your periodic table, that atomic mass that you have there is basically the average of all of the isotopes they have found of that particular element. Okay, so for oxygen, your average is 15.9999, which averages out to 16. Okay, and that's your average mass unit. And so AMU is basically what you're going to be calculating today, and that is your average. And you're gonna, this might be a question on your test. Hint, hint. Average mass unit. It's hard for me to write like that. Okay. Your AMU is your average mass unit. And that's our objective today. I'm going to show you how to calculate your average mass unit. Okay. Now, sometimes you're not going to have to calculate it. Sometimes they might give you a picture and ask you which two are the isotopes. Mija, get off the phone. Okay. Sometimes they might show you 3, 4 different elements, and they'll ask you which ones are the isotopes. Now, what's the one thing in your atom that never, ever changes? Ever. It identifies your element, your protons, your atomic number. Very good. Okay, so your atomic number is your protons. The protons never ever change. You see how here you have 8 protons and here you still have 8 protons. Because if you change those protons, it's no longer oxygen. It will be a different element. Okay? Okay, are we all good? Yes? Yes? Okay. All right. Let's take this sample. You have carbon 12. You have carbon 13, and you have carbon 14. Now, what is my atomic number for carbon? Look at your periodic table. What is your atomic number? How many protons do you have? Yep, you have 6. Very good. And so it's right there. And remember, the bottom number is your atomic number. That is your protons. And so because all of them have 6, you know that they're the same element. So they're all carbon, because that proton is what identifies your atom. If you just get the picture on a test and they ask you, actually there's going to be a question like this on your lab for tomorrow. And it's going to say, well, what's the element? All you have to do is count how many protons you have, okay? And that will identify your atom. So because you have 6, you know that it's carbon. Okay, now here, let's go ahead and find the neutrons. So because my mass is 12, remember that mass equals protons plus neutrons. And because my mass is 12, and my protons are 6, how many neutrons do I have? What am I going to do? This is from last Friday. You're going to subtract it. Very good. So 12 minus 6 gives me 6 neutrons. Good job. Okay? And so that's just a review from last Thursday and Friday. Okay, so now let's look at your second carbon. This one's carbon 13. Your mass is 13 minus 6. That gives me how many neutrons? 13 minus 6 is going to give you 7 neutrons. Very good. Okay. Now for this third isotope, you have carbon 14, a bit more hazardous. 14 minus your 6 protons is going to give me how many neutrons? 8. Very good. So you see how you have the same element, but you have a different number of neutrons. Because of that different number of neutrons, that is why you have a different mass number for each atom there. These are isotopes. Okay. Are we okay so far? Where do we have a question? Are we okay so far? Okay, and that's the difference between an ion and an isotope. The ion changes the electrons. The isotopes change the neutrons. And so those neutrons change the mass. All right. We all done with this frame? Yes? Okay. So now do an example. Now, you can have a sample that has 2 isotopes, 3, 5, or 10 isotopes, and they're all going to function the same, okay? So let's say here you have 20% in this sample of lithium-6. Let's say you have 10% here for lithium-7, and let's say you have 70% for lithium-8. Now, I'm going to give you what percentages to use, and that's how you're going to know what percent to use, okay? you are always going to know which ones are isotopes, because if the atomic number is the same, these are all the same element. Okay, but your mass is different. So what you're going to do is you're going to make that percent a standard number. So you move the decimal twice, because what's happening there? How do you make a percent into a standard number? You divide by 100, right? So moving that decimal to the left is like dividing by 100. Okay, so if you take 20 divided by 100, it's going to give you the 0.20. Yes? Are we all there? Okay. All right. So that's what you're going to do. You're going to do the mass, which is 6, times the 0.20. This is going to give you a number. And so what is that number? Go ahead and use your calculator. 6 times the 0.20 is going to give you how much? Yep, very good. And so this gives me 1.2. Okay, now let's do the second isotope. I have 10%, so we're going to move it twice. And my mass is 7. So you're going to take your mass, 7 times your 0.10, and you're going to multiply that out. And so what does that give you? Very good. It gives you 0.7. Okay, and now we're going to take the last isotope that has a mass of 8 times the standard number of 70%, which is 0.70. And what is that going to give you? 5.6? Okay, very good. Okay, and so now you've got all of your isotopes done, right? So your last step is you're going to add them all up, and this will give you your total AMU. And AMU stands for what? Average mass unit. Very good. Good job, guys. Okay, so 5.6 plus your 0.7 plus your 1.2. Yep, 7.5 is your AMU. And that's your average mass unit. Okay. And that's it. That's all you're doing. That's how you're going to calculate it. Where do we have a question so far? Are we sure? No questions? Guys, remember you can interrupt me at any time to ask where I'm getting a number or where it's coming from. We don't have any questions. None. Okay. All right, so this means, so you're going to tell me what to do. Here's an example. You have an isotope of 64 copper, 65, and 66. And you have the percents. So tell me what to do. What was that question? You have to move the decimal because it's a percent. And you have to make it into a standard number. So what's my first step going to be? To the left. Right? Because it's going to be 1.5 divided by 100. You're going to move it twice. Okay? So what's my first step? You said no, that you didn't have any questions. So what's my first step? This. Yep, 64 times the 0.015. Very good. And that's going to give you 0.96. Very good. Okay. What's my second one? 65, very good, times 0.005, because you're going to move this twice, 1, 2, right? So 0.005, and that's going to give me, very good, yes. So 0.325. Okay, what's my third one? Okay, what's the first step I do? So you're going to take the mass, 66 times 0.98, very good. Now guys, remember you must show all the work, so you can't just have like the answer, okay? So whatever you're putting in the calculator, you must write down. Okay, so what's my total? I think I heard that already. Yes, very good, 64.68. Okay, and so now your last step is you're going to add them all up to get your average mass unit. Very good. So what's my total? .965. Yes. Very good. And this is an isotope. Good job. Now your percents, for it to be a true sample, all of your percents should always add up to 100. Okay, so 98 plus 0.5 plus 1.5 does equal 100, yes. Okay, to be a true sample, because you're going to have a 100% sample, right? That's your whole sample. All right, very good. What questions do we have? Okay, guys, remember I can't tell what you're thinking unless you talk to me. All right, now isotopes are used in, and you must show all of this work. If you only have the answer that's a 0, I won't count that. Okay, you must show the work for everything for each one. Now it's really short today. Make sure you put your name on it, and you're going to turn it in up here. Okay? And that's isotopes. We'll go ahead and do a lab tomorrow. Hopefully I can get those M&Ms, and we'll do a lab on Thursday. Whoops. You know, radioactivity, forensic science. You're going to use it for half-lives, carbon dating, okay, DNA. In the science world, they're going to be important. Okay? Now, for your assignment, it's very short today.